Hello dear students, how are you doing? I hope you are doing great. Today we are going to discuss the organic compounds containing halogens, which are haloalkane and haloarene, and we are going through the chemical properties of haloalkane mainly, and we can start with the third property. We have already made two videos, nucleophilic substitution reaction and dehydrohalogenation reaction. You can go and check it out. Today we are going to discuss the third method, which is with metals. You can go with the reaction of alkyl halide with metals. So the first part of it is with Na, sodium metal, with Na. This is your sodium metal, and this is also known as Wood's reaction. So this is very famous reaction, Wood's reaction. So mainly this series are about 15 minutes videos, and you cannot get bored in 15 minutes. You can go and check out all the videos, just revise all the concepts for JEE, Neet and board exams, and yeah, just take a 2-minute, 3-minute break, then again watch other videos. Okay. So the reaction goes like that. You have alkyl halide reacts with 2Na, plus we have to basically take 2 moles of this, so we can write down again XR. This is the same compound, and the reaction goes like that. It will form mainly RR plus 2 moles of NaX. This reaction goes in the form of dry ether. The reaction will be done in dry ether presence. Okay, this is Wood's reaction. You can write down. The second reaction with metal is with zinc. When we are talking about zinc, it is known as Franklin reaction. Franklin reaction. Okay. So in this reaction, again, Rx, alkyl halide, react with zinc plus Xr. When you heat it up, it will form RR alkane plus ZnX2. If you want, you can write down the example also regarding that. CH3Cl plus Zn plus ClCH3, which is the same. It will give CH3CH3 plus ZnCl2. So this is the second reaction, which is known as Franklin reaction. You can write down. The third reaction will be with Mg. With Mg. So whenever we are talking about Mg, the main reaction will comes in our Grignard reaction, right? So this is the formation of Grignard reagent. Mainly what we have to do. This is alkyl halide reacts with Mg in the presence of dry ether. The reaction goes in the presence of dry ether, and it will form RMgX. This is also known as Grignard reagent. So the formation of Grignard reagent is from alkyl halide like that. You can remember that X is the halogen and the alkyl group in this reaction. The fourth reaction, you can consider the D part with alloy. Which alloy? Lead sodium alloy. Lead sodium alloy. The fourth reaction is lead sodium alloy. For example, we are directly writing the example in it. 4 moles of C2H5Br. This is your bromoethane. Reacts with 4 Pb, but it is alloy, so you have to write down Na also. The reaction goes like that, and it will form C2H5 whole 4 Pb, okay, plus 4 moles of NaBr plus 3 moles of again Pb. So the reaction is completed now with lead sodium alloy. The fifth reaction will be, and the last reaction in metal, with lithium. In case of lithium, the reaction goes like that. Rx plus 2 moles of Li in the presence of ether gives RLi plus LiX. The reaction goes like that. Example, CH3Cl plus 2 moles of Li in the presence of ether. It will give CH3Li plus LiCl. So this is a reaction, and you can remember that also. The next chemical reaction which we are going to discuss is the chemical reaction of alkyl halide with the reduction form. Okay, so this is the next reaction, which is the number 4th. The first one is nucleophilic substitution reaction, in which the alkyl halide is attacked by a nucleophile. A lot of nucleophiles we have discussed in our previous videos. You can go and check it out. The second one is dehydrohalogenation, in which alpha beta elimination reaction, and in that reaction mainly the alpha beta, from the alpha there is a halogen removed and from the beta there is a hydrogen removed, and it will form the alkene basically, and it will follow the Shedzev rule. So you can go check it out. And this is the third part, which is chemical reaction. So the fourth one is with reduction. Basically we are going to discuss the fourth reaction is reduction. Okay, so in the reaction Rx plus 2 hydrogen H4 or ZnHCl gives R plus HX. Okay, so the reaction you can use LiAlH4 or ZnHCl. The reaction would follow like that: CH3Cl plus 2 hydrogen LiAlH4 or ZnHCl. You can use Zn in the presence of HCl. It will give CH4 plus HCl. So this is a reaction known as reduction. The fifth reaction will be the heating effect of alkyl halide. Heating effect. In this reaction mainly R CH2 X is heated at the temperature of 560 degrees Celsius or above. It will form alkene basically, and HX will be removed. Let's do examples. The example will be CH3 CH2 CH2Cl 560 degrees Celsius, CH3CH double bond CH2 plus HCl. So these are the main reactions, heating effect. The next part of this chapter is, so next will be the chlorobenzene. Have you heard about this, right? Chlorobenzene. Chlorobenzene. So chlorobenzene will be like that. Okay, or you can write down C6H5Cl. One H is removed and the Cl is attached. Got it? So we are going to understand the method of preparation of chlorobenzene. Method of preparation. Okay. So method of preparation will be the first method from benzene itself. From benzene itself. The first method is from benzene. So you can write down, if there is a benzene, it is added with Cl2, right? The reaction follows in cold and dark FeX3. It could be FeCl3 or whatever. It will form chlorobenzene, right? Plus HCl is removed. So this is the reaction follows when benzene is treated with Cl2, right? It will form the chlorobenzene. The second method, which is very important in commercial purpose, you can write down commercial method. Large scale you can obtain commercial method, or it is also known as Rastrick method. This will be your, suppose you have benzene, right? Benzene is added with HCl and O2, half moles of O2, in the presence of Cu2Cl2, Cu2Cl2, it will give again chlorobenzene. Both are the symbol of benzenes. Chlorobenzene plus water is removed. So this is the method. This is called commercial method. Benzene is added with HCl and O2, and it will form the chlorobenzene plus H2O. The third method we are going to use is from alcohol. That's again the easiest method. Just take the phenol, add PCl5 in it, PCl5, right? Heat it up. The OH will be removed and it will form chlorobenzene. This is chlorobenzene plus acid will be removed, POCl3 removed plus HCl. So this is the third method of preparation of chlorobenzene from alcohol. The first one is from benzene itself, second Rastrick method, third is alcohol. Fourth one we are going to discuss mainly, that is again very famous, from diazonium chloride, benzene diazonium chloride. From benzene, write down with me diazonium and subscribe the channel also. Diazonium chloride. This is mainly known as Sand-Meyer reaction. What do you call it? Sand-Meyer reaction. This is mainly known as Sand-Meyer reaction. Let's discuss. So this is your benzene attached with N, double bond N, Cl. Okay. When Cu2Cl2 attack on it in the presence of HCl, it will form chlorobenzene plus N2 gas removed. Okay. This N2 will remove and this will form chlorobenzene. Is the proper mechanism of it. The fifth is Gattermann reaction. After Sand-Meyer, we have Gattermann reaction. Okay. So in the case of Gattermann reaction, we have N double bond N. Cl again is heated up in the presence of Cu. It will form chlorobenzene plus N2 gas removed. N2 gas removed. So this is the property of Gattermann reaction. That's again Sand-Meyer and Gattermanns are same, only the reagent vary. Next we are going to discuss the physical properties. Physical properties are aryl halides are colorless. Aryl halides are aryl. Benzene we are talking about. Chlorobenzene. Colorless liquids. And colorless solid. Colorless solids also with characteristic odor. They have some kind of odor. The chlorobenzene is colorless liquid. The chlorobenzene is colorless liquid with a pleasant smell. Its smell is pleasant.